Assalamualaikum warahmatullahi taala wabarakatuh. I hope everyone have a nice day today. This video content of our final year group project entitled Modification of Chaum van Antwerpen signature scheme using elliptic curve cryptography. For your information, our supervisor is Sir Mat Nizam bin Udin. I am Muhammad Khairul Aslam. We lead the presentation as presenter number 1. Cryptography. Do you have ever heard cryptography? Okay, I'm gonna explain what is cryptography. Cryptography is method of protecting information, communication through the use of codes, so that only for those whom the information is intended can read and process it. The prefix crypt mean hidden or vault, and the suffix graphy stands for writing. Based on Karandika in 2007, cryptography is the procedure of how to conceal data from expected foes or programmers. The sender encodes a message with a little bit of mystery data, and afterwards send the encrypted message to the recipient. At that point, the recipient decrypts an encrypted message with a key that is the same or not the same as the utilized by the sender to recuperate the first message. Next is Chaum and van Antwerpen. Who is Chaum and van Antwerpen? Actually, these two person, David Chaum and Hans van Antwerpen, is one who proposed an undeniable signature. An undeniable signature is a digital scheme allow the signer to be selective to whom they allow to verify signature. The scheme adds explicit signature repudiation, preventing a signer later refusing to verify a signer by omission, which is a situation that would be devalue the signature in the eyes of verifier. Today, it is well known as Chaum van Antwerpen signature scheme. Next is elliptic curve cryptography, or we call it as ECC. ECC was proposed by Victor Miller and Neil Koblitz in 1985 as an alternative for established public key systems such as DSA and RSA. ECC is an approach to public key cryptography based on the algebraic structure of elliptic curve over finite fields. Based on finite fields, ECC allows smaller key compared to non-ECC to provide equivalent security. Elliptic curves are applicable for key agreement, digital signature, pseudo-random generators, and other tasks. Indirectly, they can be used for encryption by combining the key agreement with a symmetric encryption scheme. This is why ECC has faster computation, reduction in processing and power bandwidth. Next, I will proceed with problem statement. From the previous study, Chaum van Antwerpen signature scheme was applied in positive integer over prime number. This kind of situation also be applied in elliptic curve cryptography. However, the researcher does not explain the algorithm clearly. From this problem, we want to show and demonstrate the combining both between Chaum van Antwerpen signature scheme and elliptic curve cryptography, and develop the algorithm for the proposed protocol. Next is objective. From the problem statement that we have stated before, we have discovered two objectives for our final year project, which is number 1, to implement Chaum van Antwerpen signature scheme using elliptic curve cryptography, And the second one, to develop algorithm for the purpose protocol.
Assalamualaikum warahmatullahi wabarakatuh. Today I will present about the design discussion. Part 1. Setup and elliptic curve. Alice and Bob will decide a prime number which such that p equal to 23, the value of a which is equal to -1 and b equal to 10, where the value of a and b is satisfy the discriminant d equal to 4a cubed plus 27b squared not equal to 0 mod p. Thus, the elliptic equation is y squared equal to x cubed minus x plus 10 mod 23. Then Alice and Bob will make a list point that lies on the elliptic curve and assign its point with their respective order by using addition and multiplication law of elliptic curve. Part 2. Signing algorithm and verification algorithm. Signing algorithm. Alice will choose a point alpha such that 14.7 which is equal to 2g and her private key which is a equal to 3. Then she will compute the signature beta such that a alpha mod p, which we will get the value of signature beta which is equal to 6g mod 23, which is equal to the point of 13. Then Alice will choose a number of k where k is value between 1 to 23. Then Alice will compute point k where generator is multiplied by k value modulus p. Then we will get point k which is 71 and the x coordinate of point k is labeled as r. Then Alice will compute value of s where s is equal to k inverse multiple z plus r a mod p. Thus we will get s value is s31. Then Alice will sign the signature h which is 0.23 equal to 10g, signature beta which is equal to 0.813, message m 0.1514, the value of digit z which is equal to 10, point alpha which is 14.7, and the pen number of rs which is 721 to the box. Verification algorithm. Bob will compute the value of w u1 and u2 where w is equal to sin s inverse mod p which is equal to 11, u1 z w mod p which is equal to 18, u2 rw mod p equal to 8. Then Bob will compute the value of c using the two coefficients of u1 and u2 with the value of h and beta where C equal to U1 H plus U2 beta mod P, then we will get C equal to 21G, which is equal to 0.1416. Then Bob will pass this C value to Alice. So Alice we can put the D value such that D equal to A inverse C mod P, where we will get the value of D, which is equal to 7G.
Okay, the last one is conclusion and recommendation. In a nutshell, the objective of this study to conduct a research about cryptography technique. Our objective, which is to implement Chaum and open signature scheme using elliptic curve cryptography, has been achieved. We have demonstrated the combining both between Chaum and open signature scheme and elliptic curve cryptography and developed the algorithm for the proposed protocol. Hence, it will make the signer and the receiver safe to encrypt and decrypt a message. For a recommendation, this study can be helpful for future research due to lack of research according to Chaum and open signature scheme using elliptic curve cryptography from previous researchers. Hence, we hope that our study can make it clear for other researchers to continue in studying about cryptography, especially for Chaum and open signature scheme and elliptic curve cryptography. Thank you.